This will be for the con assignment, expected value. So just real quick, the formula for expected value, E of x, equals the sum of x times P of x. All right, this symbol here is a Greek letter sigma. It means the sum of. And x is each individual value, and P of x is the probability of each individual value. So you're going to multiply the value times its probability and keep doing that, and you take the sum. You basically add them up. So it says x is a discrete random variable. The graph below defines a probability distribution for x. What is the expected value of x? All right, let's see. So on the x-axis here, we have the values for x, -5, 0, and +5. And on the y-axis, we have our probabilities. All right, so let's find the value for each one. Right here, the value for x is -5, and its probability is 0.2. All right, so that is going to be, I'll just write all the probabilities on top at first. All right, this one is 0.2. And for 0, the probability is 0.4. And for 5, the probability is the same, 0.4. All right, so we're going to take the sum. All right, we're doing the sum of x times P of x. It sounds fancy, but it's very easy. All right, so the first one, x is -5, and its probability is 0.2. All right, and we're going to add that to the next one. 0 has a chance of 0.4. So x is 0, and its probability is 0.4. And then finally, the last one, x is 5, and the probability of 5 is also 0.4. All right, so you can just do that on the calculator. And I just get 1. Okay, of course, you can just skip this one right here because 0 times 0.4, obviously that's 0. So you don't even have to write it, or if you want to write it, you don't even have to enter it in the calculator. So the expected value is 1. A scratch-off lottery ticket costs $5. If the ticket wins, it can be redeemed for $100. If the ticket loses, it's worthless. According to the lottery's website, 4% of all tickets are winners. The expected value of buying a ticket is -$1. All right, let's see. So the scratch-off lottery ticket costs $5. Okay, it's guaranteed that you have to buy it. So if it costs $5, that's -5. All right, and it's guaranteed that you actually have to buy the ticket. So that's 100% guarantee. And if you convert that to a decimal, 100% is just 1. All right, so the expected value for -5, it's 100%. So it's -5 times 1. All right, and if the ticket wins, you win $100. And if the ticket loses, it's worthless. Okay, according to the lottery website, 4% of all tickets are winners. So the chance of getting $100 is 4%, or 0.04. And if the ticket loses, it's worth 0. Okay, so you can put plus 0 times 96% if you want. If it's a 4% chance of winning, there's a 96% chance that it loses, okay? But that's just times 0, so you don't need it. All right, so if I do this on the calculator, it's going to be -5 times 100, -5 plus 100 times 0.04, okay? And that's -1. All right, but they told us that already. The expected value is -1. So I just wanted to prove it to you. But let's see. It says choose all answers that apply. Might be more than one answer. If you bought 5 tickets, you would certainly lose money. Well, no, that's not true. Okay? One of the tickets might be a winner. Okay? And if you bought 5 tickets, that's only $25. You only need 1 ticket to win. So you can't say that. A is definitely wrong. If you bought a small number of tickets, it is possible for you to make money. Of course that's true. Okay, you might buy only 1 ticket and make money. You might buy 2 and make money. It depends if you get a winner. See, if you bought a large number of tickets, you should expect the average value to be about -$1 per ticket. Yes, that's true. We calculated it, and they told us anyway the expected outcome would be -$1. All right, so that's the case for each purchase. So if you bought a large number of tickets, the average would be -1 per ticket. That's true. All right, that's the whole point of the expected value, to give you the average value for each purchase. All right, X is a discrete random variable. The table below defines the probability distribution for X. What is the expected value? Okay, very easy. All you have to do is multiply each value times the probability of it occurring. All right, so I'm going to do -10 times 0.47. I'm going to do 5 times 0.21 and 10 times 0.32. All right, and then you just add those together. All right, so -10 times 0.47 plus 5 times 0.21 plus 10 times 0.32. And I get -0.45. Or -0.45, same thing. That's it. So you click in the box, and you can enter -0.45 or 0.45. John just bought a brand new cell phone, is considering buying a warranty. The warranty costs €200 and is worth €100 if his phone breaks. John estimates that there is a 10% chance of his phone breaking. Find the expected value of the warranty. All right, so it says the warranty costs €200. That is a given. If you buy the warranty, there's a 100% chance it's going to cost you €200. Okay, and since it's costing you, that's going to be -200. All right, and there's a 100% chance of that occurring. All right, and it's worth €1,000 if €1,000 if the phone breaks, and there's a 10% chance that it breaks. Okay, so we're going to add €1,000, and there's a 10% chance of that. All right, so all we have to do is convert to decimal. 100% is just 1. And 10%, you move the decimal over 2 places, that's 0.1. Or you can say 0.10, same thing. All right, so I don't even need the calculator. That's going to be -200. Oh, I wrote 100, but they said $1,000. Let me fix that. Okay, so 1,000 times 10% is just 100. So -200 plus 100 is just 100. -100. You just enter that in the box. All right, so basically this is saying the warranty is probably not worth it. In all likelihood, you're just going to lose money.